Welcome, everybody. This is the Rotary E-Club of Silicon Valley. Every week, we bring you the stories of people making a difference in the world, locally, globally, and digitally. We are part of Rotary International, over 1 million people in over 30,000 clubs around the world who believe in service above self. Our club has a special interest in innovation, entrepreneurship, and education, and we look for stories that we think are amazing in terms of their impact, the kinds of things that can give us hope for the future. And the program we have today is exactly such a program because it addresses one of the most vexing problems that we as a global society face, and that is the effects of a warming climate. And so with that, we have with us today Pascal Martin Daguet. And Pascal, if I have butchered the pronunciation of your name, I apologize. But bienvenue to the Rotary E-Club of Silicon Valley. We are excited to have you here. Everyone, as you watch this recording, if you'd like the full bio, simply pause and on the web page where you found this, either our Rotary page at siliconvalleyrotary.com or on our YouTube channel or on any of our podcast feeds, then feel free to pause and take that in. But I'll also ask that Pascal tell us a little bit about himself as well. Pascal, we are so honored to have you. Welcome to the Rotary E-Club of Silicon Valley.
Thank you. Thank you so much, Rushton. So I'm going to talk to you about Re-icing, which has the incredible project of preserving and restoring Arctic ice to slow climate change. Okay, this company was formed 5 years ago in the UK. We are registered in Wales. And we have, as a partner, the University of Cambridge and its Center for Climate Repair. As for me, I joined the company in October as Chief Operating Officer. My goal is to scale up the operations and to make this enormous project happen. I'm a civil engineer by profession, and so I work on this project now since October. The Arctic, you may know that, is a very important ecosystem for the Earth, just like tropical forest or coral reefs. Firstly, for the living of the local population and animals that you can see here, but also because it actually regulates the whole temperature of the Earth. It's like a giant fridge that's affecting what you can see on this image, the jet stream. The jet stream is that air that is going around the planet. And what happens in the Arctic affects what happens in Europe, in the US as well, in Africa. So it actually regulates the whole climate. The reason for that is that during summer months, the ice of the Arctic acts as a giant mirror and reflects an enormous quantity of heat back into space. You can see on your right, it's called albedo effect. And in one day of summer, it can reflect 16,000 terawatt-hour of sun, which is equivalent of 6 months of human energy production around the world. And the effect on the climate is that 1 square kilometer of ice is equivalent to 7,000 tons of CO2 removed from the atmosphere. Unfortunately, the Arctic is melting because of climate change, and there is less and less ice present during summer. You can see on the left side is called the Arctic spiral of death, because you can see as the months passes and the years passing, the summer ice is getting smaller and smaller. You can see from 1979, when the first satellites started to do measurements, until 2023, you can see that almost half of it has shrunk. The quantity of the mass of ice has shrunk enormously in terms of volume. Almost 75% of it is lost. And in terms of extent, so on the surface, almost half of it is lost, 40% is lost. Which means that what remains during summertime is a very thin layer of ice, probably 1 meter thick only. It's a bit like your ice cubes in your drink. When they start melting first, the thickness will go smaller, and then you have only small pieces of ice on top that will go on the surface that will melt very quickly. That's where we are now. And it's estimated that before 2040, there'll be no more summer ice. Therefore, all the energy that was previously reflected back to space will be absorbed mostly by the sea, which has the potential of which is going to increase drastically the effect of climate change, and in particular, melting of permafrost. And one of the main goals for real ice is to slow down the tipping points like permafrost and melting of Greenland. But there is a way to preserve summer ice, which is a very simple way. It consists in wintertime of pumping seawater on top of existing ice to thicken the ice so that during summertime there is enough ice left to reflect sun rays and heat to space. How we do that? We have ice covered by snow during winter. If we pump seawater on top of the snow, then we flood the snow and we create new ice. And because we have removed the snow blanket, which acts as an insulator, then you have an increase of ice underneath because of increased conductivity. You can see on the right side at the bottom of this hole, the blue ice is the old ice and the new ice is the one that we have created on top of it. So it's actually a very simple process, which consists in just pumping water on top of ice. We have done already 2 trials. You can see here where we have to go on the left side. We do our research in Cambridge Bay, which is north of Canada, because there's the Arctic Center there that we can use. We have a ship that's going from Montreal once per year only through the Arctic Circle to deliver the equipment, so it's kind of difficult to do. Last winter, in January, we have managed to create 1,000 tons of ice just with a small pump, the one you saw on the previous image. And what is important in our project is we work with the local community of Inuits because their way of life is in danger as well. There's less and less ice, and that's the way they've been living for centuries. So we work with them to engage them in what we are doing. So now you have understood that the Arctic is really important for the climate. You understood also that making ice with seawater is easy to do. It works. Now, what we have to do is to continue to study how to make ice and how it behaves from one season to the other. We also have to study how the ice that we have created impacts the rest of the environment. In particular, the new ice on top of the existing ice is more salty than the existing ice, and we have measured that the ice can migrate through the old ice to go back into the sea. And our next challenge is not to make ice on an industrial level, because what we plan to do is what you see on the left side of the photo of the image is to re-ice the border of the Arctic on 1 million square kilometer per year, which is a huge quantity to do. So we have to create ice at an industrial level. If we can do that, the payoff is huge because we could slow down climate change from probably a few decades. Give more time to the world to decarbonize its economies. To do ice on an industrial level, we have chosen the method of using underwater drones that you can see here. This will be unmanned automated vehicles that would go from a floating station that would go under the ice, drill a hole through the ice, pump water during 8 to 10 hours, and then go back to their floating station to refuel. The fuel that we are going to use is hydrogen, green hydrogen, which we'll need in large quantities. Realize in numbers, as I just told you, our plan is to re-ice 1 million square kilometer per year to have a significant impact on climate change. To do this, we would need 500,000 of drones. Seems to be an enormous quantity, but when you look at a car manufacturing company, it's actually feasible. We will need almost 1,000 floating stations to be spread around the Arctic, which is around 3,000 kilometers long. So it means the barges will be spread 30 kilometers from each other. We would need a large quantity of green hydrogen, around 70,000 tons of it, more than 10,000 people working during the winter months. And the budget for the 10 years, it's around $50 billion, which is quite small compared to the damage of climate change and the payoff of re-icing. Our budget, half of the budget is actually from the energy, so from hydrogen. This is how we plan to scale up things. We have 4 different stages. We are the first stage, which is research and development. We are starting now we have done the first 2 stages, which is T1 and T2. This we're testing of pouring water on top of ice and see how it behaves. That functions. Our next target is the next expedition is in November, where we will continue to re-ice on different parameters to see how the ice behave. We'll have 1 session in November, 1 in January. And my main target for the moment is what we call D1, which will be winter 2026-2027. It's in 2.5 years' time. This will be the first time we would be creating ice on an industrial level. We would use the drones. We would have 50 drones that we would use during 3 months, day and night, 24/7, to make 100 square kilometers of ice. From there, that's our proof of concept. From there on, what we need is to scale things up. We need to have a drone factory. We need to produce a few 100,000 drones, and then we need to, in 10 to 11 years, we would be at the maintenance regime, where we would have not only stop the decrease of ice, but actually recreated ice. Of course, to get there, we have a lot of challenges. The main one for the moment is to design and build prototypes of these drones. Last week, I was in Germany talking to automotive companies because I think they have the capability, the engineering, and also the testing labs to be able to help us with that. We'll have to, of course, design and build these floating stations, which will have to work in very tough conditions in winter. There's a lot of wind. There's the currents, there's the ice, there's the cold. We have to go through maritime and Arctic regulations, which is not easy because the Arctic is surrounded by, it belongs to 8 different countries, which includes Russia. And the last problem, probably the least, but it's very important issue, it's funding. Of course, funding 50 billion it's not easy. This is our team. We have a core management team, which is a mixed team of younger and more experienced people. We have an advisory board, and we have scientific advisors as well. What I have to mention here is that all of us are volunteers. None of us are paid. We do this because it's a great project. It's not every day that you get to save the world, and because it's fun to do too. So here, what we need today is to find industrial partners to design and test the drones. We have already donations for next expedition, but we need donations for the next expedition, like next year. And of course, we are applying for a lot of international funding, and we need help to do these things. So if you want to help, if you know people who want to help, you have my email address, and you can contact me. And then to finish, I'm going to show you a small video of what our last expedition. So we've drilled through the ice here. We put the pump in the hole. This is our fuel cell. We have a hydrogen fuel cell.
Fuel cell operation to just fuel cell.
And then we start pumping water. And this is how we put this 1,000 tons of hydrogen, of ice, and you can see the ice. So after flooding, it creates like little flowers that are quite beautiful. It's minus 40 degrees, by the way, at that time outside. After that, we core the ice to make some measurements, check the salinity, check the temperature, salinity in the lab. Thank you.
All right. Pascal, what an amazing story. I am excited for us to get into the Q&A for this. First thing I will do, though, is introduce the group that we have on the recording from the Rotary E-Club of Silicon Valley, and wave when I call your name, our president in Vancouver, Canada, Nick, our president-elect in the Sacramento area, Mike. We have here in the Bay Area, Lisa. We have in Houston, Texas, Rory. We have our treasurer in Italy, Cecilia. And we have friend of the club, Christine Buring in Germany. My name is Rushton Hurley. I'm in San Jose, California, and I will start the questions. So Pascal, when we look at this, we're talking about a project of significant proportions, right? One thing that you don't mention in the admittedly short time frame we gave you is about your background. Could you talk a little bit about the kind of work you have done before, so that people understand why you decided to get involved?
Oh, yes, sure. I'm a civil engineer, and I work as a project manager for around a period of around 30 years on the large construction projects around the world, most of them bridges, which includes the longest cable bridge in the world, which is in Vladivostok, so Far East Russia, where we also work by minus 30 degrees. That's why I have a little bit of experience in working in those conditions. The main difference is that in Vladivostok, it's a city of 500,000 people. You can find things. Where we go in the Arctic, there's not much. So my background is project management.
And in doing something like this, is it the case that when you got in, because it's Kian who is the founder, is that correct?
Yes.
How did you connect with him?
Kian was the founder. He started this when he was a student at the end of his studies in Wales. And he was very lucky, very fortunate to be called by a serial entrepreneur, his name is Simon Woods, who came in and started to organize the company. And Simon is an old friend of mine. And after a while, he realized that when the money will be there, they would need to scale things up, and they don't know how to do this. But he saw me in Malaysia. We were together in Malaysia. He saw that I was working on a bridge and doing big projects, so he called me to see if I would be interested. And of course, I said yes. And he said, "We can't pay you." And I said, "It's perfect."
Well, the nature of international connections for making something this bold happen is consistent with what happens in Rotary as well. I like that. Mike
Absolutely.
asks a great question. Is the density of the new ice the same as the established ice, or is it more likely to melt faster? Are you envisioning operations as a non-for-profit? And what role will the 8 governments play in financing?
Okay, there are 3 questions there. So the first one, firstly, the fresh ice, I would say, is more salty than the existing ice. That's because salt migrates through ice to go back into the sea. And so the fresh ice is more fragile than the existing ice, and also reflects the sunlight a bit less. But we have done some measurements. We came back in May this year, last month, to measure the salinity of the ice that we had created. And we realized that salt actually migrates from the old ice through the new ice back into the sea. And so our new ice, after a few months, is less salty and it becomes stronger. So its density is better and becomes stronger. The second is we are not for-profit company because we want to attract government and international funds, grants. And also we have an open concept, because we want to attract other people to do the same thing as us. It's a huge effort, having 500,000 drones. It's a huge endeavor. And we think that we should not be alone to do this. And we hope to attract other people to do something similar.
Well, the bold nature of the effort, I think, would be part of how you get that story out there. And do you have a people on the team who are marketing specialists who are thinking in terms of the kind of innovative partnerships that might be necessary to achieve the goals?
we all do this in a certain way. I mean, last week I was in Stuttgart at exhibition of innovation for car manufacturers, and we presented with Ken. We presented this to the car manufacturers. We got a good response actually. They seem to be very interested. So that we also do the marketing, the promotion, and it's actually what I'm doing with you today. I'm doing the promotion of what we do, just spreading the word.
Perfect.
Even though I'm just an engineer, and it's not my, I'm not into marketing, but I can explain with my own words, not perfectly, but I can explain from the heart.
Well, I think the opportunity to tell the story and why you're involved is exactly the kind of thing that allows people to be interested in Re-ice or Rotary's efforts or anything like it. Christine, who's in Germany, actually asks which company it is in Stuttgart that.
We went to the Startup Autobahn in Stuttgart. It was an exhibition of startups, and I think we attracted the attention of, I hope, Mercedes-Benz.
Excellent. Well, we are quite energetically developing a group right now in Germany of startup-minded people who are excited about innovative service. The next question is from Nick. Nick, go ahead and unmute.
Yeah, my curiosity is around the hydrogen because it ties into, for me, sustainability. Electric cars are great for, short range, but if you think about trucking and things like yours where you need a fuel source that isn't going to just be charging some battery, is that where, are you thinking about the car manufacturers from a manufacturing the drones perspective, from the hydrogen, from both? Because it seems like car manufacturers would be interested potentially in both.
You saw on the image, the drones are 2 meter long. They are automated vehicles. They are powered by hydrogen, so they look like a simple small car. And I think the car manufacturers, they have the engineering and they have the capability to develop such a large number of drones. So I think they would be a good fit for us. But if you are talking in terms of producing the hydrogen, I go to hydrogen trade fairs as well because we need to find green hydrogen. And what I found is that east coast of Canada, Labrador and Newfoundland start to want to develop large facilities of green hydrogen production because they have wind and because they have a lot of land. And I think that'll be a good interesting area for us because it's the entry to go to the Arctic too. And we would need to refuel all our stations on the Arctic.
In terms of the power requirements, you mentioned that there is a significant wind in the Arctic in the winter when the teams would need to operate there. Is the wind a potential source of power for your stations, your refueling stations?
Originally, we thought about that, and we may use it for our testing station in Canada. But if it is for the full operation, I think it's too unstable, too remote, too dangerous. It's going to be difficult to keep those floating stations at the same position. We need dynamic positioning systems, and we'll have people who will live on those barges. Even the fishing boats don't go there in winter. The sea is too chaotic. So I think we need to produce our energy somewhere a bit more stable, and it's in very large quantities. 70,000 tons of hydrogen is a lot. We need to have an area that is an industrial area and can create hydrogen on an industrial scale. What I found in Newfoundland and Labrador seems to be the right place and the right size.
All right. Lisa asked a question about your funding, and I remember you saying at one point a little bit about the work happening in the United Kingdom, and that some of the initial funding is coming through a grant there. Is that correct?
Yes. We received donation. We are applying for grants now from the UK government. The fact that I'm French and our co-CEO is Italian, also we have that's Europe because UK is not Europe anymore. So we are planning to apply to European funds as well.
Another technical question from Mike. So with these drones under the ice, how do the connections work with a control center for the larger operation?
So the drones will be attached to a floating station. They'll communicate underwater between themselves, and they're all autonomous. They communicate like bees in a hive or robots, in a warehouse. That's the system we want to use. And then when they come back to their station, then they can download also all their data. Because they'll have to map the ice from below and from above as well when they are drilling. So there's a lot of data to be manipulated and computed.
Can you also say a little bit about the geographical choices? So the Arctic is not the only place where there is melting ice. I believe you are considering certain kinds of operations in Greenland, and you're testing in northern Canada. Are there other places around the world where there is diminishing ice and this same technology can be used?
Antarctica is also melting really, really fast, but it's a continent, so you have to. How do you find water to pour on top of the ice? That's the main challenge. You are in the Arctic. It's a sea covered with a little bit of ice that's only 1 meter thick, and it's easy to pump seawater on top of the existing ice because it's all there. So you need to find a place where you have ice and where you have water, both. Antarctica will be difficult.
That makes sense. As we wind down the time for the recording, could you come back to the story of how you are involved? You mentioned that no one is being paid, that this is essentially an effort, an international effort among people who really care about this topic. How did you decide this would be worth a tremendous amount of your own personal time? I mean, can you talk a little bit about the personal connection to the project?
Well, I've been involved in this kind of, environmental or social project for all my career, actually, for a long time, and I've always wanted to save the world. I've been into environment for probably 25 years, interested by those topics. And the chairman who really helped the company to go where it is today, we knew each other, and then he contacted me because to be part of the team. And firstly, I thought, wow, this is such a crazy project. But then I looked into it, and 500,000 drones that's not that is feasible. Human beings have done more than that. Working in the Arctic, it's difficult, but we have sent people to the moon, so we should be able to do that. $50 billion, it's a lot of money, but not compared to, comparatively, it's not that much actually. The damage from climate change is a few $100 billion per year. So it is feasible. And on an engineering point of view and project management point of view, it's also feasible. So I did my own due diligence, and I realized that it is actually feasible. And the impact, it's an effort because it's a difficult environment, but the payoff is so huge. 1 square kilometer of ice, as I told you, equates to 7,000 tons of CO2 removed from the atmosphere. So it's a lot. You put a little bit of energy, and you can get a huge payoff. So it's worth it.
Well, that is absolutely the heart of someone dedicated to service. So I will wind things down. Afterwards, we'll do what we always do, which is to continue talking to these interesting people that we record. We love doing that. And Pascal, before we finish the recording itself, I'll hand it back to you for a final word. But first, to all of you who are watching this recording or listening to one of our podcasts, thank you so much for taking your time to seek out the kind of inspiration that allows us all to tap into the very best parts of ourselves, those parts that allow us to think about what service can mean in a meaningful life, that we can dedicate our time and energy and our stories to help make this world a better place. And so we appreciate your taking time, and that you will continue to take a look. You can learn more about our club by going to our site, siliconvalleyrotary.com, or the shortcut, rotary.cool, which it is. And with that, I will ask that we have our speaker give us the final word for the recording. Pascal, we always like to hand it back to the speaker. What is that you'd like to have people thinking about as they finish watching the video or listening to the podcast?
Well, I love this project. As I said, I'm not paid, but I wake up every morning thinking that it's it's a wonderful opportunity to be able to save the world. It's not every day that this happens, and that's real service about self.
Well said. Everyone, thank you for joining us. We will see you next week.